problem, especially for the ones who aren't here. That'll be good. So can you see that? Can you see that PowerPoint there?
Yep.
Yep. Okay. Brilliant. So this camera should move along. Everyone can see that whiteboard okay, yeah?
Yeah.
So what is artificial intelligence? Anybody, what do you believe artificial intelligence can be? There's no one definition. James, Joshua, what do you think artificial intelligence is? Yeah. Reactive thing. Program. Something like that. So everybody else, what do you think when you hear artificial intelligence? What do you think? Like I say, there's no wrong answer.
It makes me think of Google.
Google, yeah. Google. So I suppose technology. Thomas, what about you? What do you think when you hear artificial intelligence?
Sort of reactionary, I guess kind of like machines reacting to specific inputs.
Yeah, reacting to input. So the user gives an output and it goes through artificial intelligence and the machine gives an output. One more. Connor, what about you? What do you think when you hear the term artificial intelligence?
I honestly think of like machine learning.
Yeah. So machine learning is a stream of AI. What about robots? Anybody think of robots when they hear artificial intelligence? Computers? Yep. Matrix?
Yeah, Terminator, Matrix, all those.
Okay, I think like Wall-E, but all right. Everyone kicking off with the apocalypse.
What was that, sorry?
Wall-E?
Wall-E.
Wall-E? So all of this encompasses artificial intelligence. Like I say, there's no right or wrong answer, but machines being reactive to users' input using technology, that's all AI is. So we use artificial intelligence every day. Can anybody give me an example of when you would use artificial intelligence in your day-to-day life?
Machine that starts to work out.
That's like a human example. So artificial intelligence is basically a machine doing the job of a human. So a machine taking over what a human used to do. So what about using the self-checkout in Tesco? Does anybody have an Alexa or Google Home? Wake everyone's Alexa up. Yep. Alexa, Google Home, they're all artificial intelligence. Does anybody watch Netflix?
Mhm.
When Netflix gives you recommendations to watch new shows, that's a form of artificial intelligence. They're taking your data, they're taking the shows that you've watched before, looking at the genre, looking at the type of films or series that you watch. They're putting that into a model and giving you recommendations based upon that.
What's the difference between algorithm?
It uses an algorithm to give you.
So
There's an algorithm underpinning. Yeah. So an algorithm is basically a model written. That's all an algorithm is. So a set of code. You have an input, it goes through the algorithm, and you get an output.
the algorithm is the the algorithm.
AI uses the algorithm. Yeah.
What are the limits of AI? Sorry, I can't.
Yeah. Go ahead.
So I don't know if someone in class was talking where it's kind of hard to hear when someone in class is talking, but I was just wondering what are the limits? Like would an ATM, would that be considered AI considering it does the job of a bank teller? But it's like fairly basic.
Yeah, it's a basic form of AI. Yes, definitely it is. It's a basic form of artificial intelligence because, like you say, yeah, it's doing the job of the bank teller.
Okay.
So let's get started up. Does everybody have Canvas? And yeah, just let me know if you don't have Canvas. I've put the slides up there as well, and they're on Teams on class materials. I'll try and turn up this volume as well on the. Is that any better for you at home for listening, for hearing?
I bet, yeah, it was just more static interference. It's probably just the distance of the camera.
Yeah.
Oh, sorry, the microphone in the camera.
There's a microphone in the camera, yeah. We are getting better mics, faster mics for presenting, so.
No worries.
Okay, machine learning. So today's class will go through an overview of artificial intelligence. Like I say, machine learning is one stream of artificial intelligence. Artificial intelligence encompasses so many things, from the ATM to Netflix recommendations. So machine learning is one stream of that. So today we'll go through an introduction to artificial intelligence, history of AI, common AI elements, risks and challenges of AI, and responsible AI. So firstly, an introduction to AI. So AI is all around us. Like I say, it's in our homes, our TVs, Netflix, even on Facebook when you get ads, targeted ads, they're using your data, and they're giving you an ad as an output to what you might like. In our local shops, so self-checkout and more. AI is the ability of a machine to carry out human tasks. So that could be to create shopping lists. So Alexa or Google Home set timers to change the TV channel, to turn the music volume up or down. So a show of hands on Teams there, the virtual hands, who has an Alexa or a Google Home? James and Josh, do you think either? Do you use Siri? Yeah, Siri is a form of AI. So there's quite a few of you there. So AI can follow a stringent set of rules given by its developer. And this rule is called an algorithm. So an algorithm is basically a line of code, which is like a recipe. The computer follows it line by line. So the computer is programmed to give out a certain response depending on the input. So the code will say, if input is X, output is Y. The computer, the algorithm, won't go off of that. If it has an input it doesn't understand, then it won't function. It won't give a readable output. So it needs an input that's already been defined. It goes through a specific set of rules and gives an output. That's what an algorithm is in layman's terms. Does that make sense? So anybody just shout, use at home as well if you have any questions. But yeah, an algorithm is basically a line of code, which is a set of rules, which gives an output depending on the input. So AI also includes the ability for a machine to learn, to build and refine its own model based on historic events, so based on past data, and this is called machine learning. So machine learning is different than an algorithm. A machine learning is when the machine can learn itself through new observations. So a machine is given a load of data and it builds its own model to predict output. Each time a new observation is recorded, the machine will refine its model and it'll learn that way. So Netflix recommendations, each time you watch a new show, the model will be refined. That's a form of machine learning. The model will be refined and you'll get different recommendations based upon the new show that you've watched. So machine learning, as it says, is the ability for a machine to learn itself to build a model. So an algorithm is just a stringent set of rules. The machine doesn't have much intelligence. It just has this line of code. It's given an input. It knows what to output. Machine learning is when the machine, the artificial intelligence, goes a step further, and based on the input, it creates its own model and refines that model based on more observation. So what exactly is AI? In this video.
What exactly is artificial intelligence? We speak of AI when computer systems perform tasks that usually require human intelligence. This includes, for example, recognizing images, making decisions, or engaging in dialogue. To do this, the AI systems must be equipped with knowledge and experience. This can be achieved in two ways. You can program each individual instruction so that the machine solves the task step by step. This is comparable to a cooking recipe or assembly instructions. Alternatively, you can use programs that learn from data themselves. This enables them to detect relevant information, draw conclusions, or make predictions. This is known as machine learning. We all have probably dealt with AI at some point in our lives. When we watch films, listen to music, or shop online, AI gives us recommendations about what we might like. AI is capable of converting spoken language into text and translating it into other languages. AI is a central component of robotics. Robots make our everyday lives easier or take on strenuous activities. Self-driving vehicles recognize their environment through AI and can react to it. AI is becoming increasingly important within medicine. It supports doctors when diagnosing diseases. Also, more and more patients use AI-based apps for initial diagnosis. In the educational sector, AI helps to individualize learning activities, for example, on digital learning platforms. AI is becoming increasingly important. Once we understand how AI works, we can better gauge where it can support everyday activities at home and at work, and where we would rather make our own decisions. AI will not replace humans, but it is getting better and better at supporting us. For this, we need an AI competent society.
Okay, great. So self-driving cars, has anybody heard of Tesla? That's a form of AI. You can see Elon Musk there on artificial intelligence. Okay, so AI progression timeline, a bit of a history on AI. So, without looking at that timeline, when would you suppose AI came about? When would you suppose the idea, the concept of AI started? Do you think it was fairly recent? What does everybody think in the past 10 years, 20 years, 50 years?
Yeah, probably since the turn of the millennium.
What was that? The turn of the millennium?
Yeah.
Yeah, so about 20 years ago. Anybody else?
I'm going to say, I'll take back what I said before and guess way further, like back in World War II.
World War II, yeah. Yeah. That's a good
Yeah,
guess.
probably when the first computer was built.
Yeah. So, 1947, a mathematician, Alan Turing, gave a lecture on the concept of machines becoming intelligent. At this stage, it was well outside of the scope of what humans thought could happen. Machines becoming intelligent, machines were only recently introduced. But Turing argued that if a machine could pretend to be a human without the human at the other end knowing that it was a machine, then it should be considered intelligent. So this is called the Turing test, and you'll hear this quite often in artificial intelligence. So the Turing test, has anybody ever talked with one of those chatbots when you're doing your online banking or something like that, or you're on a website and you're going through customer service? Those chatbots are pretty basic, but the Turing test basically says, we know they're a machine, by the way, but if you didn't know that it was a machine at the other end, if you thought that it was a human, and if that machine could pass as human, then that's considered artificial intelligence. And then Arthur Samuel coined the term machine learning in 1969. So it took more than a decade later, defining machine learning as the field of study that gives computers the ability to learn without being explicitly programmed. Remember what we said before, an algorithm is a specific set of rules. It's just a program that's written. The machine just follows step by step. So one of those chatbots is a form of an algorithm. And we'll look at creating chatbots later on in the course. But if the user puts in a chatbot for a shop, for example, what is your opening hours? That chatbot, you know, it already has a specific set of rules there that says if the input is regarding opening hours, give this output. And that's why it takes the class. It's already there. It's not thinking about it. It's just giving what it's supposed to give. So in 1950, the Turing test was developed, and that's a method for determining the intelligence of a machine. So artificial intelligence, it's just the intelligence of a machine. It's not real intelligence, it's artificial intelligence. It's just a machine, how intelligent a machine is. The term AI was coined in the mid-50s then, and by 1966, one of the first chatbots simulated conversations pretending to be a psychotherapist. So this was one that could pass the Turing test, and that's when it was found then to be artificially intelligent. So the first chatbot was actually created in 1966, and that's what, up to 5 years ago. Between the 70s and 1910, there was a pause in artificial intelligence, and this is known as a winter in research. This is known as the artificial intelligence winter, and it was because of several reasons, mainly because computers weren't really powerful enough at the time to process artificial intelligence. There wasn't enough capacity in machines. Near the millennium then, a chess computer, Deep Blue, won against the chess world champion, and this is when things started coming to light. Media was getting involved. The world champion was beat, so this machine must be intelligent. In 2011, Siri was integrated into the iPhone 4S for the first time, and there was a lot of hype about this as well, for the iPhone 4S for Siri. Then the same year, the supercomputer Watson won against two human rivals in Jeopardy. If anybody knows the quiz show Jeopardy. In 2014, Alexa moves into people's homes. So Alexa was being produced behind the scenes, and it was only in 2014 then Alexa was actually mass produced and sold to the public. In 2016, a chatbot had to be reissued because of discriminatory remarks, and we'll go through later as well the challenges and risks of AI, bias and things like that these machines can have. In 2017, AlphaGo beat the world champion in the game Go. And in 2018, the legislation is always behind in these kind of things, especially in the likes of technology when it's so fast moving and ever changing. The regulation takes a while to catch up. So in 2018 then, the ethics guidelines were established from the European Union, and they were guidelines to deal with ethics in artificial intelligence. So the age of AI. So artificial intelligence has become a significant part of our daily lives, and we are now thought to be living through the age of AI. So you'll see many researchers saying this, many scientists, many people involved in technology. This is the age of artificial intelligence. So you can see here smart speaker sales, Amazon Echo, so Alexa, the Alexa device, Google Home, Apple HomePod, and Facebook Portal. You can see their sales from the past 4 years, from 20 over, it's grown sixfold in the past 4 years. So you can see how much that's increasing, how much artificial intelligence is becoming mainstream, it's becoming the norm. How people now will talk to their remote control, press the button and say, turn into a TV or play a telegraph, play a certain film. Everything's becoming more accessible. Smart speakers are in the range of what, 30, 40 pounds. So the job landscape, by 2025, so this is data from the World Economic Forum on the future of jobs. By 2025, new jobs will emerge in certain industries and others will be displaced by a shift in division between labor between humans and machines. So you can see here the decreasing job demand, data entry clerks, because that'll all be automated, admin work, executive secretaries will no longer be needed, bookkeeping, clerks, accountants and auditors. So there's a lot of accounting software at the minute, really good accounting software, which means that accounts can be automated. Business and services and administration, So this will all go down. This is all decreasing job demand, and that's expected to go down by 85 million jobs by 2025. 97 million new jobs are expected in the next 4 years, mainly in data analysis and data science, artificial intelligence and machine learning specialists, big data specialists, digital marketing strategy specialists, automation specialists, business development professionals, digital transformation, information security, software and application developers, and Internet of Things specialists. So you can see the growing job demand is all in technology. Technology is the forefront of the job market at the minute. And if you understand artificial intelligence, then you have a massive step up. So common elements of artificial intelligence. So AI software imitates human behavior and capabilities. So like I said before, artificial intelligence is wide ranging, it's vast. So where humans used to make decisions before based on their past experience, AI now does that through machine learning. So based on past data, observations, machine learning builds the model to make predictions. Each time a new observation is made, machine learning will automatically, without the intervention of the human, will automatically refine that model until it's more precise, more accurate, better at predicting. Detecting anomalies. So anomaly detection is a form of AI, which is the automatic capability to detect errors or unusual activity. Interpreting visual input, so computer vision. So AI has the ability to interpret the world visually through CCTV and images. Has anybody watched the show on Channel 4, Hunted? Anybody watch Hunted? So it's basically these fugitives, it's really interesting show. 12 fugitives go on the run. 12 people, normal people, they get a drop-off point and they go on the run. They have no information about them. And the police officers and detectives use technology. It'll be on Channel 4 on demand, I'm sure. The police officers use technology to find them and hunt them down. They might be in fields, they might be at the other side of the country, they could be anywhere. But technology, they use technology to track them down, and that's through tracking phones, through the use of CCTV, facial recognition. CCTV can recognize people's faces through the use of the cars. There's software that can read number plates. So when you're going down the motorway, if you see a camera, it'll be reading your number plate. It could be checking if your car is taxed, MOT. So there's AI is all around us. And computer vision is a really big one actually. There's a really good app. It's called Seeing AI for Apple. Let me see, I have it. Try and get you the icon for it. It's really good. I would suggest everybody downloading it. To give you a flavour of what vision entails. Yeah, so that's the app. So anybody has an iPhone, you can get it from Apple Store. It's free to download. It's a really, really good app.
Identify products based on their barcode with Seeing AI.
So Seeing AI plays audio cues to give you an indication of when it first recognizes the possible presence of a barcode. The faster the beeps, the closer you are, and then eventually you'll hear a description of what the product is. So for example, here I have a jar. I'm going to hold the phone over the jar parallel with it. Maybe.
Sorry, you guys from home, I know you can see that really well. I'll put the URL in the chat. and I'll play it through Teams. Make it a bit easier for you.
Christine, it's playing on our screen as well, so it is.
Oh, is it playing in your screen
Yeah.
already? Okay, brilliant. There we go.
1 foot away. The distance to the object depends on how big it is. The larger, the further away you would want to be. So the phone is over the jar and I'm not hearing anything. So let's slowly rotate it until we hit those beeps. There are our beeps, so let's keep going.
Processing. Barney Butter Barney and Company. Almond Butter Crunchy. Button.
Cool, peanut butter. I like that. Let's try something else. I have another product here. This time it's a box. And with a box, there are 6 possible sides which I'd have to scan. In actual fact, it could be anywhere on those 6 sides. So I'm going to hold the phone quite a bit further away this time so that the camera can see the entirety of one side at a time. So we're not seeing anything on that side. And try another one. Ooh, that's lucky.
Annie's homegrown microwavable gluten-free mac and cheese 5 CT.
Wow, great. So mac and cheese, and I was lucky. I got it on the second side this time. So to recap, we use barcodes to identify what a product is. Hold the phone over the object you want to recognize, maybe about a foot away, but you should try different distances based on the size. Make sure the phone is parallel and start rotating the object until you hear the beeps. Make slight adjustments until the beeping gets faster and you hear the description read out. Sometimes you'll hear that more information is available, like the instructions on the package. Now, I better get back to putting away my groceries.
Microsoft logo appears.
Okay, so like I say, it's a really useful app. I would definitely recommend everybody downloading it because it would give you a really good flavour of computer vision in AI. So it can do lots of things. It can read text. It can change handwriting. It can change handwriting into a text document. Computer vision can recognize faces. It can, like I say, recognize number plates. It can recognize objects in the scene. It can give it a picture. Then it'll say this looks like a computer screen, classroom. You can do a selfie mode where it says this looks like you know, a 33-year-old male looking cafe in the selfie mode. So it's definitely a really good good app. And I'm sure there's an Android version as well. But yeah, I just downloaded it in my phone. So common elements of AI. So interpreting visual input, like I say, computer vision, understanding written and spoken language. So we'll go through all these in detail throughout the course. We'll go through them one by one in detail, but natural language processing. So this is the ability of a computer to interpret written or spoken language. So Google Home or Alexa will interpret spoken language. Written language, anybody use the Google text translator? If you take a lump of text written in some language, put it into Google Translate and it translates it immediately for you. Google has an add-on as well, whereby if you're on, for example, a French web page, you can have the Google add-on translate the whole page for you, and going through that website, it'll translate everything that's in French, it'll translate it to English for you. So there's loads of good add-ons. There's an add-on as well on Google where it'll basically read out all the text on the page. So to save you from reading, there's an add-on that'll basically just speak out all the text, and you can change the speed of it, you can change the accent of it, you can change whether it's a male or a female, where they're from, and all that. That's all forms of AI as well. Even Audible, when a book written in text can be changed to a human point of voice. That's form of AI. So engaging in dialogues and conversations. So conversational AI, the capability of a software engine known as a bot to participate in conversation. So like I say, this is the like if you go into your online banking and somebody is saying, hello, how can I help you today? You ask it a question and it already has, and its knowledge bank, it already has this question and an answer already written for you. So the next slide. Examples of AI. We went through a couple of these in the class. So we use AI regularly and we might not even realise it. I think there was only 2 people, I think, that said examples of when they use AI during the day. But we use artificial intelligence regularly and we might not even know it. So Siri helps us find information, get directions. It uses machine learning to get smarter and understand questions and requests. So has anybody ever used Google Maps? Yeah, Google Maps is your sat nav. Google Maps will tell you to get somewhere, and that isn't just a predefined, Derry to Belfast. That's going to be 90 minutes regardless of traffic, regardless of time of the day. It's not like that. Google Maps is a machine learning form of AI, so that'll change depending on the time of the day, what it knows if it's a busy time of the day. If there's congestion, it'll add on some time. If it's been noted that there's an incident on the road, then it'll add on more time. So anytime the Google Map gets information about your route, it'll add on or take off time. And that's all through past observations, through other people traveling that route, giving their information to Google and saying, okay, on average it takes 90 minutes, but on a Monday morning at 9 a.m. it'll take 2.5 hours. There's an incident happened today, or there's roadworks, or there's congestion or something. Every time a user gives that information to Google, Google will update your time, and it's not a human doing that. At the other end, it's the machine. That's a form of machine learning. It's always updating based on new information, new observations. It'll always keep updating. It'll keep checking for new information, keep refreshing, and update the time to make sure that it's most accurate as possible for you, for the user. So Tesla, I'm sure most people have heard of Tesla. So these are the self-driving cars, and they have predictive capabilities. Netflix. So Netflix uses predictive technology to offer recommendations based on users' reaction. So this is whenever you rate film or a series on Netflix, if you give it 1 star, it's not going to give you a similar type of film again. If you rate it 4 or 5 stars, it might say, okay, they enjoyed that. They might like something of the same. Based on your reaction, based on your review, based on your interest, depending on what type of genre you enjoy, if you enjoy horror, if you enjoy comedy, if you enjoy romance, that's the type of recommendations you'll get. In my case, I have 2 young boys, so I get recommendations of Peppa Pig and Paw Patrol and all lovely stuff like that. So AI challenges and the rest. So AI is a very powerful tool, and it can really, really benefit the world, benefit users all the time, but it must be used responsibly. There's a lot of risks associated with AI, which must be understood. So AI can be biased. So a loan model might discriminate against gender just based on the data that it was trained with. Data isn't always quite accurate. There could be anomalies, there could be data, there could be things in there that throws the model off. So the model is only as good as the information that it's given, and it might discriminate against gender or other characteristics. It could discriminate against demographics, it could be ages, discriminate against age, and so on. So errors can cause harm. So an autonomous vehicle, so a self-driving car causes a collision. Who's responsible for that? A self-driving car drives into a tree. Who's responsible for that? So it can cause harm. So you have to use these things with caution. So data could be those. So a medical diagnostic bot. So AI is used in healthcare more and more and more. It's used all the time now in healthcare to help with making diagnoses, to help with finding, you know, the machines are becoming more and more, they're becoming a lot better, they're becoming a lot smarter. So a medical diagnostic bot is trained using sensitive patient data, which has been stored in a secure place. So there can be errors in these machines. Solutions may not work for everyone, so a home automation assistant provides no audio output for visually impaired users. So AI is becoming more and more accessible, and that's something that a lot of companies are working towards. So you've seen that in AI video, the guy was visually impaired, and technology is actually helping him now read barcodes, look to see what money is, see in AI, if you put a note in front of it, a £20 note or a £5 note, it'll tell you this is a £5 note sterling, £1 note sterling. So it really helps the visually impaired and stops them with that. So users must trust a complex system. So a lot of the time, obviously this course, the purpose of this course is to give you guys the knowledge into what built, how are these models built, what goes on behind it, what's the methodology, understanding these machines, so you can build your own model so that you can understand and explain to somebody that doesn't understand why this machine is doing what it's doing. You can say in layman's terms, this is exactly what it's doing, this is the output you got, and this is why. Who is liable for AI vision? So an innocent person is convicted of a crime based on facial recognition evidence. Who is responsible? So like I say, there's a form of AI called facial recognition. So within about ever uploaded Facebook photos to Facebook, and it says, this looks like such and such, do you want to tag them? That's facial recognition. Or does anybody have the photos on their phone? It goes through your photos and says, this looks like such and such, do you want to put it in their folder, do you want to categorize it as them? That's all facial recognition. So facial recognition is also used in the justice system, it's used in court. So if somebody's convicted for a crime because they were caught on CCTV doing it, but it's not actually their face, the computer saying this face looks very similar to the one that committed the crime, who's responsible for that. So there is some challenges and risks that we should be aware of. So AI bias. What to do.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool in the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation, because technology should work for everyone.
Okay, great. So can anybody tell me a form of bias that a computer can give without meaning to? So any form of bias, how can the machine become biased?
I know that there's a problem with whenever Asian people are in photos, it's asking them, is someone got their eyes closed? Has been a problem for Windows phones.
Yep. Yep, very good. Anyone else?
I know there's like automated lifts that weren't detecting people with certain skin tones. There's been an issue of bias in the past. It's obviously just because they tested it on the, yeah.
Yeah, and that could be just because the test data, the data that they've used to build the model, didn't include a diverse enough set of observations, a diverse set of people. So yeah, that's another really good one. Has anyone else heard of any or think that there could be any more forms of bias?
When Apple's facial recognition launched, was it not a bug maybe where any Asian person could open any other Asian person's phone because it was recognizing the faces were similar?
Yeah, that was another one. Not any other Asian person, but people who look similar were able to get through the Face ID.
Yeah, and that's heavily biased. So we'll have a look ourselves. So there has been a lot of stories in the media, and we'll break into groups now and have a discussion. So I've listed 4 here. So we'll break into 4 groups. What is there? 14 of us. So suppose you two can work together, and then we'll do 3 groups of 3. 4 groups of 3. Right, so we'll do one twice. So below 4 examples of biased AI, and these are news stories. Obviously, there's another few there that were really good as well. Below 4 examples of biased AI, choose one of them and research what the problem with it was and how it was found. We'll break into teams. I'll give the online guys now, I'll break these into teams to research these examples, and then we'll have a class discussion. So each team then will kind of tell us, a bit of background on the story. What was it? Was it really biased? What was the outcome of it? How was it found? And what happened next? So if you two guys, please do the first one. Amazon sexy hiring algorithm. Just give that a Google and you come up with something on it. And then we'll do Matthew, Thomas, and Connor. Who's want to do number 1 as well? Yeah.
Which Matthew?
Matthew Ward. Sorry, Matthew Ward.
Yep.
Thomas Wood and Connor Murray. And then Michelle, Ronan, and David Moore, if you want to do number 2.
Okay.
Victoria, David Murphy. I think we've had a couple of people drop off. So Victoria and David Murphy, if you want to do number 3, Facebook's algorithm bias. And then, sorry, you guys, just want to do number 4 instead, then at least it's split out.
Yeah.
Yeah, you do number 4 instead, and then at least we have a group doing each of them. So feel free to have set up a team meeting between the 3 of you.
Sorry, Christine, I don't know if I didn't hear my name or if I got skipped over.
Who's that? Sorry,
Matthew Robb.
Matthew Robb. Sorry, Matthew. So who do we have? We have Matthew Ward, Thomas Wood, and Connor. We have Michelle, Michelle Ronan, and Matthew Robb.
Okay.
Yeah. So if you do number 2.
2.
Yeah.
Perfect. Thank you.
No worries. So if we reconvene here at 10:20, and we'll all go through each of the scenarios. So yeah, feel free to have a new Teams call with your group, or whatever you think works best.
Oh, yeah.
Hiya. Good. Yeah, yeah. There's just two.
We've got a good rate of people on Friday ones on.
Aye, all the yep. So they're in here all day, is that right? Aye, I'm here all day.
COVID and all that sort of practice, thank you. Yeah, I've got you, but double up again. But last year, there's dwindled down to about
Let me turn
3 or
this
4 people.
camera around. Jeff's in the spotlight.
Jeff, do you know work to be doing?
Flat out.
Flat out. Joking.
I'm just taking a wee break. See you guys, missed you all.
Are you missing us now?
What?
Devastated you're not teaching us?
Catch up later. I did last year's, I think they're now second year, they're doing years and left. Double them up, classes, get you new cases in. There may be some join us online. It works right. But yeah, same room. Things are all the same. But you've got your laptops again, so you can
David Murr said hi, Jeff.
Oh,
Mine's
hi.
not working.
Okay, how are you? So we'll catch up later.
Yep.
All right, happy enough, guys. The bars, everybody's good.
All good, yeah.
See you there. Cheers. All right.
Yeah. Right, so everybody's discussed each of their scenarios. Do you guys want to go first for number one? Turn the camera on here. Oh, sorry, number 4. We changed it, didn't we?
Yeah, I'll try and give a sort of generic overview of what the problem was, and then let Josh go into the stats. So the basic reason behind this, there was an algorithm that was set up to find out to place patients at high risk problems kind of at the front of the queue for more personalized and more urgent medical care. But the way the algorithm was set up, it was to use cost as the primary label for who was at the most risk. So the thought process being, if I cost the medical system 50 grand on healthcare in a year and Josh cost him 30 grand, well then I'm probably higher at risk. So I'm going to need more personalized care and need to be close to that queue. So theory being worst patients need close care. But the problem with using cost was that for various reasons and for back to cost the healthcare system less despite being more sick. So there's a quote here saying because black patients generate fewer costs than white patients at the health level. So what that meant was that sort of healthier white people were generally being put in front of less healthy black people because they cost the system. So the study in 2018 identified that only 17.7% of the algorithm assigned healthcare were black, and the rest were all white. Right? Done without that bias, it should bias.
So it's quite general and I don't think rhetorical, but basically it said that out of 50,000 people, 26%, so the black people have a 26.3% chance higher of having a solid bonus than on the same data as white people. And that was caused by the diversity. But it was that people automatically gave 26% higher chance of having a bonus. Data was the data was the same white people. That's caused by data.
Yeah. So how should the algorithm prioritize healthcare? What is the fairest way? I mean, this is an open question. This is subjective. Anybody can answer, but is cost a good measure? How should it prioritize? It can't go through, each individual patient. There are going to be millions. It can go through each one and, rank them one day, whatever. So what would you, if you were building a model like that, what kind of feature would you say should be prioritized?
Severity of illness.
Age.
Yeah, so severity being marked 1 to 5, 5 being critical and 1 being minor, something like that.
Yeah.
Yeah, somebody else said age.
Yeah, like how there's no point giving, say, a liver to someone who's 72 is going to have a stroke next week. Do you know what I mean? If you give it to like a younger person, or like the ability to divide the organ. Like if you've got a liver, you can divide it into like 2 or 3, and it'll provide the same job. Same with the lung. Do you know what I mean?
Yeah, so it's all really subjective. I get what you're saying with the age if somebody's 72, but if a 72-year-old, was your dad or your uncle, you would still want them to have it. So medical and healthcare is really subjective as to how we can prioritize. So would you prioritize, for example, somebody that's older with a more critical illness, or somebody who's younger with a minor illness? There's so many variables to it.
I think though as well, like prioritizing people based on like maybe how noisy their family is, or how much like support they have, it's kind of going to be classist eventually long term, because those people with more money are going to have like more support in terms of like income and stuff to be able to make that noise and try and get that organ.
Yeah, so sometimes in healthcare as well, it's who shouts the loudest, who does have the status, who is able to get up the list, which unfortunately isn't always the fairest way.
Yeah, like hospitals and stuff are going to prioritise people who can make like multi £100,000 or £1 million donations and things like that,
Yeah, which is also biased. It's based on class, it's based on wealth, and that's not always how these things should be prioritised. But definitely a really good point, because that does happen. Any other variables people would consider when you're building a model to prioritise patients? So we've looked at their wealth and their status, we've looked at their age, and we've looked at how critical their illness is. Obviously, this model used cost to determine priority, the highest cost being the highest priority.
You have to like factor in against unconscious bias. So Black women are more likely to die in healthcare than their white counterparts after childbirth, 4 times more likely to die or suffer serious illness compared to white counterparts for no other reason other than their race. So it's really important that not only are you aware of any bias that might be there, but that you actively work to make sure that that unconscious bias that has affected for so long is like countered against to make it fair. Yeah, definitely, because we want all these patients that we're operating on them, we want them to be viable, and we want everybody to have a successful recovery. And like you say, if a Black woman unfortunately was less likely to recover, then that bias could be built into the model and say they're less viable, which is completely biased and unfair. So being aware of that bias. Because of machine learning, they will pick up on like patterns that they've seen, and if they see that, say for example, Black women are more likely to not survive an operation, then they're going to be, the machine learning is going to skew towards not giving those operations to those women because they're seen as being less likely to survive, but that's because of the bias that's outside of the machine learning,
Yeah, definitely. So that's why it's really, really important. Bias is a really important thing to be aware of in machine learning, because it can come down to a life or death operation, somebody not getting an operation based on these factors that might be biased, that might be out of their control and can be completely unfair. So no matter, you could have all the statistics in the world, but you always have to test your model for bias, all forms of bias, age, race, gender, class, all forms of bias. So that was a really interesting one on healthcare. So Tom, Connor, and Michelle, was it for number 1? Is that right?
Go, Matthew.
Oh, sorry, Matthew. Yeah, go ahead for number one. So Amazon's sexist hiring algorithm for 2018. What did you guys find out on that?
All right, so Amazon had an AI system trained on data submitted by applicants over a 10-year period, and most of it came from men. It was for software engineer jobs and technical posts. And one of the engineers said that the Amazon bosses wanted it to be an engine where they give it 100 resumes and it spits out the top 5, and those are the ones hired, like just based purely on the application. Yeah. So it started in 2014, and by 2015, it became clear that it wasn't rating candidates in a gender neutral way because it was built on data accumulated from CVs submitted mostly from men. And problems with the data that made the model's judgments meant that unqualified candidates were often recommended for jobs that they weren't fit for. And the system preferred words like action-oriented words like executed or captured. If CVs had words like that in it, they were more likely to be successful. And if CVs included the word women, for example, if an applicant was a women's chess club captain, or if they were from certain all-women colleges, it would downgrade them, and they were less likely to be successful, even for that. And so it was edited to make it neutral once they realized the problem, but they weren't sure how to solve it so that other biases wouldn't appear or wouldn't crop up. And then it was abandoned in early 2017. And but Reuters said that it was used for a while by recruiters who looked at the recommendations, but they never actually solely relied upon it. And that's all we got.
Yeah, no, that's really interesting. So, yeah, I suppose, like I say, machine learning, it can be very subjective. So if you do have 100 male applicants, 80 male applicants and 20 female applicants, should you choose 8 male and 2 female just to get, the right proportion, or should you choose all male if they're more qualified? So you can over select as well. So just say you wanted to make it fair. There was 80 male applicants, so you chose 8 males to interview. There was 20 females, so you choose 2 of them, even though they weren't qualified. That's trying to make something fair, when they might not necessarily be a good fit. It's just trying to stratify that way. So yeah, no, that's a really interesting one, and it was abandoned then, but it was just used for information. Yeah.
Yeah, it looks like they relied on it for a while, but then when the bias came out, then some people used it as a tool in combination with other stuff, but
yeah,
the first
so they say.
Really relied upon. Yeah, so they say.
Yeah. So that's another really good one. But like I say, when these things eventually come to the media, when they come to the forefront and when people find out about them, they are quickly oftentimes dismissed then, because no company wants to be seen as being sexist, especially in employment, or being biased.
I like how they just weren't able to fix it. Like, even after they tried to fix it, it just still couldn't be trusted. Like, trust seems to be a thing with AI.
Oh, definitely, massively. And we will go through that later on as well this morning. We'll go through trusting AI, because things like bias is always there. Human unconscious bias is always there, and people aren't always aware of it. Only then, when you see it in black and white, it does become clear. When you see the numbers, of people employed or people interviewed, only then can you see bias. But unconscious bias is everywhere. People just automatically, when they see someone or think something, they'll have learnt behaviors, and they'll exhibit bias. But having automation and having a machine is one way that we should be able to get rid of that. Okay, brilliant. So thanks for that, Connor, for taking us through. So the next group on number 2, the correctional offender management profiling for the alternative sanctions clause. So this is when AI is used in court systems.
It's a quarter mouthful, so I'll just refer to it as Compass.
Yeah, yeah.
So basically, the software itself uses an algorithm to look at potential risks of individuals reoffending, and there's a number of different risk scores and scales. So considering things such as current charges, pending charges, employment status, community ties, residential stability, goes on to consider criminal history, associates, maybe drug involvement, things like that there, and also things such as violence, so history of violence, history of non-compliance, and even thinking about, from vocational and educational problems, also takes on board the person's age at intake and the person's age at first arrest. So the algorithm in the Compass software, as I say, it's used to try and predict the risk of somebody reoffending them. So the flaw itself, in a nutshell, comes down to skin color. So there's a series of investigations done, and as part of that investigation, the team found that blacks are almost twice as likely as whites to be labelled a higher risk, but not actually reoffend. Whereas the Compass software makes the opposite mistake amongst whites, that they're much more likely than blacks to be labelled lower risk, but go on to commit other crimes. And there's another finding that only 20% of people predicted to commit violent crimes actually went on to do so. It's just quite a way off the mark then. So there's a series of publications, a series of investigations done, and it came out that there's a lot of controversy amongst it, a lot of conflicting information, and that it couldn't necessarily be considered completely trustworthy. So whilst it can still be allowed, it has to come with an additional warning that the scores represents, in terms of what the score represents, and that there are limitations and cautions within the tools. But because of the sensitivities within the algorithm, they can't actually just open it to the public to allow a full investigation. Besides, there's a number of reports that contradict several comprehensive studies, concluding that the actuarial risk can be predicted free of racial and or gender bias.
Yeah, so that's a really, really interesting one where AI is used. And I think the Compass score is still, judges can still look at it and kind of have it as something to look at, but not necessarily give their judgment on.
Accuracy at the minute, it's only in around the 65% mark.
Yeah, yeah. But it's one of them. Because the court system is already subjective, it is an interesting one, because a judge might give somebody a lower sentence and thinking they might not reoffend based on their experience, and they will, or they do, and the opposite is true as well. Or maybe somebody's, found guilty when they're actually innocent. That does happen with human error as well. So it's kind of weighing up this human error and human built bias compared with the bias that AI exhibits. But that's why it's always really important to test these models and to score them, because even knowing that metric, knowing that finding whites were lower risk to reoffend when they were actually higher, that's only found out then when the data from the model, the predicted data, is actually compared with the actual data. And the same is true with blacks as well, that we thought that they were less or more likely to reoffend when they were actually less likely to reoffend. And that'll come to light then when the model is scored, when the model is evaluated, and it's actually said, we predicted this to be a reoffense, but it's actually not. And we'll look and do that next week. That's the classification model. We'll look into that, and that's we'll look at confusion matrices, and that we'll go into that in more detail. But that's a way of evaluating how our model is working. Does anybody have any other thoughts on that one? Using AI for the justice system is a big risk, isn't it?
Yeah, I think even the fact that they're allowed to consult it is because you're saying like it's such a subjective thing to begin with. It's either going to influence people to side along with the AI if they believe that's a sort of technology that is useful or confirms their own biases, or if they're like, oh, I don't want a machine doing my job or whatever, they might go against what it's saying, even what it's saying is sensible.
Yeah, exactly. So yeah, like you say, it could be, the thing that sways one decision or another if the judge is kind of on the fence. There was an article about somebody tried to claim against this Compass score, thinking that they were, their sentence was was longer than it should have been because of the Compass score, but it turned out then that the judge, it would have been the same sentence without the Compass score anyway. The judge kind of referred to it, but he didn't use it to make its final judgment. But yeah, definitely having things like this could easily sway decisions one way or another.
Is there not huge ethical concerns with using kind of like machine learning to literally pass judgment on people? If machine learning goes on past history, that is always like the way machine learning learns is through what information's already come its way. There's no way to shake off the bias on that. Do you know what I mean?
Yeah,
like even
exactly.
at the moment, there's a lot of bias from humans in that system. Surely handing it over to a machine seems even worse.
Yeah, so these, like you say, these models are built on past performance, on past experience, and on history. And a lot of the time, people's history, what somebody did in the past, can and does predict what they're going to do in the future. But of course, people can change, because just because somebody might have committed, several crimes in the past doesn't mean that they will in the future. So yeah, there's always going to be bias present, but it's just about, when we have it in a machine, it's about managing that, it's about being aware of that, and it's about trying to reduce that as much as possible. But we will go in, we will have a look at the ethical guidelines as well. Like we said at the start of the slideshow, it takes a lot of time for regulations to catch up on new industries, and especially in tech, because it's moving so fast, taken even longer for the regulations to catch up. But there is ethical guidelines now in the past few years to try and reduce this. Okay, brilliant. And then the last one, number 3, so Facebook's ad algorithm bias of 2019.
Yeah, so Facebook was found to disproportionately show certain types of ads to certain types of users based on their gender, race, and religion. So it was a study led by the University of Southern California, but Northeastern University expanded on it and found, just a whole lot of stuff. All of the systems were more likely to present ads based to users on their history. So, for example, preschool teachers and secretaries were shown to more women, whereas janitors and taxi drivers were more likely to be shown to minorities. Ads for homes for sale were shown more to white users, where ads for rentals were shown to minorities. So things like ads for jobs in lumber were shown to ads for things like lumber, 72% of the people shown the ad were white, whereas for ads for a taxi driver, only 29% of the people shown it were white. So then that was kind of cast across, based on gender and stuff, more likely to go to males for lumber, whereas stuff like preschool and the supermarket were less than 20% of the people shown the ad were male.
Yeah. So if we think, just playing devil's advocate here, so if we do expect more females to go for, the preschool jobs than males, should we be approaching more females? Open question. What does everybody think? If we expect more females to be going for preschool jobs, should we be advertising that more to females than males?
I think we should be advertising it based on that user's past history, as opposed to taking it over. So it shouldn't be necessarily a white user. It should be users that have looked for jobs in the supermarket, or looked for taxi jobs, or looked for rentals, as opposed to saying white people are more likely to buy a house.
Yeah. So individualizing and maybe building in more individual traits rather than these classifications, these characteristics, and demographics and age and race and things like that. It would be better to look at individually, what have you done in your past.
Yeah, so like if we're looking, it doesn't necessarily need to be so like individual, but instead of grouping people based on their ethnicity, we can group them based on what type of jobs they're looking at, Are they looking at service industry jobs? Are they looking at office jobs? Instead of separating them by male or female, are they more likely to search for like things that require an Amazon like certification, or someone who's with a Linux one, you know, things like that. Change the categories we're separating on so that they're not these contentious ones, essentially.
Yeah, and we'll see that a lot when we're building these machine learning models. We'll be choosing which variables to include, and it's very important to be conscious of what variables you're choosing and why you're choosing them. You know, if you don't need to, if you shouldn't be using gender, if you shouldn't be using age, if you shouldn't be using race.
Why you're tracking them, yeah, essentially.
Yeah. When you're building these models, be sure that you have a very good reason if you need to use a specific characteristic, a personal characteristic with that. Otherwise,
it's lazy. Programming to be separating people based on something they're not allowed to separate people on. Like, no harm, the amount of information they get off us, they can separate us on a whole lot of stuff other than these like 5 contentious categories. Do you know what I mean? It's literally just like, don't separate people on their gender, don't separate them on their sexual orientation, their religion, their race. Do you know what I mean? They're not, it's not that hard to get. Yeah, you can search them, like separate them on a whole bunch of other stuff. You're just making your own job harder by separating on stuff they're not allowed to do.
Yeah, and some of these models are built automatically, so automatic machine learning. We'll look into that later as well, but because they're built automatically, they might use characteristics that we wouldn't if we were building the model manually. They could use, you know, if they think gender is influencing the model, then they could include that. So it's just something for us to be aware of when we're building models ourselves. It's very important, not to use these personal traits and have a very good reason, you know, if we are.
Just on that point, I've got a follow-up question, if that's okay.
Yeah, sure.
So if we have machine learning that's making machine learning, is there any way we can say to set it so that it doesn't use those characteristics, or will it just kind of figure out what the best thing is based on the information it's given?
So there's 2 things we can do. We can build the model ourselves and then allow the machine to refine it. So it only uses the features that we allow it to, but it might give, you know, different weighting to different features depending on the new data it's given. Or we can use automatic machine learning, which builds the model itself from the ground up. But yeah, we can build a model and say, don't use X, Y, and Z, you know, we can specify which features we want it to use. Okay.
Sorry, I was thinking there, is it possible for us, sorry if I'm melting everybody's head, is it possible for us, for those automatic ones, to exclude certain ones? So, yeah, or will it just do its own thing?
No, we'll always have control over the models, so we can always go in and adjust them, or say, you know, take out this, include this. So yeah, we can always change them. We'll always have control over it. The purpose of an automatic model is just that we allow the model to build itself based on the data. You know, it's basically easier for the developer, you know, if it's built automatically. But yeah, we always have control and autonomy over the model, and we can always change it as we see fit. So humans will always have that control over it.
Thank you. Sorry, everyone.
No problem. Right, we're going to take a break now. We'll aim usually to take a break between 11 and 15:15, but just because we're going to go and get James and Josh's student cards, we'll take a break now, and we'll come back just say 11:20. And yeah, you guys, when you're next on campus, just give me a shout next week or whenever you're back in, and we'll get everybody else's student cards sorted as well. Does anybody have any questions before we take a break? No? Okay, brilliant. We'll come back then at 20:20. Have a cup of tea.
Cheers. Thank you.
See ya.
Thank you.
Right, everyone, is that us all back? Put your camera
so.
and check everybody's back. Happy days. Okay, we'll crack on. Right, so one thing that I need to mention to you as well, emails go into your Belfast Met account. I'm not sure if everybody checks their Belfast Met emails every day, but just because we're doing this in the COVID world at the minute, there might be some emails that we send out saying, you know, we'll be delivering class from home today, or everybody log on remotely today. So it's really important to check your emails every week to save somebody traveling, you know, when they don't have to or something like that. So I've just put a wee document up on Teams under class materials. It's called forwarding emails or something like that. And it just shows you how to automatically forward your emails that go to your Belfast Met account, to your live account, to your Outlook or something that you might look at more regularly. So just in case there's any update. Okay, great. So we left off at AI bias. Okay. Can everybody see that on Teams? Everyone can see AI errors causing harm?
Yep. Yep.
There we go. So, like we've seen in the last slide, and we've been through those 4 case studies, bias is something to really be aware of when you're building these models, when you're using artificial intelligence. It's really important that you choose the variables, choose the features for the right reasons, and you're not choosing things that discriminate, like gender, like race, like age, like sexual orientation, like wealth or income or anything like that. It's really important that you choose the features for the right reasons. So the next topic we'll look at is errors causing harm. So how artificial intelligence can be harmful. And we touched earlier on Tesla, so the self-driving cars, how they're at the forefront of artificial intelligence at the minute. And there's 2 case studies here. One of Uber self-driving cars that were in a crash, and another of a Tesla self-driving car that was in a crash. So if you were able to, would you choose a self-driving car or a manual car if you had the option? Would you trust a self-driving car?
Manual every day.
You would trust it? Or manual every day?
Yep, manual.
Manual, yeah. Would anybody trust the self-driving car? Would anybody sit in the passenger seat and let the car with this brand new technology drive you from A to B? Yeah. Yeah. Or maybe if you could do a hybrid, if you were sitting in the driver's seat, and if it was in self-driving mode, because you see autopilot on planes and things like that, that's been about for years. Why not self-driving cars? But they do have limitations. So you can see here 2 crashes, but do be mindful that there's crashes all the time. Every day there's crashes in the road due to human error. It's just these self-driving cars, when they're in a crash, it's a lot more media involved. There's a lot more limelight kind of put on it. So there's a wee video here. About the Uber self-driving crash.
You guys at home, are you seeing the screen, or are you seeing?
Still the PowerPoint.
You're still seeing the PowerPoint? Okay, one sec. Can you see that now?
Yeah, that's YouTube now.
Yeah.
Okay, brilliant.
In this particular condition, at night, dry conditions, I would expect all of the systems to be working, but if we're talking about which systems then would become the predominant system to look for potentially crossing pedestrians, bicyclists, anyone near or around the road, the primary sensor would be LiDAR. So LiDAR is using basically lasers to get distances on potential obstacles in the path. So if we were to look at the LiDAR of this picture, we should see really the potentially maybe that car way out in the front, maybe trees, any hard obstacles. But at this point in the film, given that we know a pedestrian is coming up, the pedestrian should have been detected at this point in time by the car. The darkness, shadows, these should not have any effect on a LiDAR's ability to pick out an obstacle in this field.
And as far as I could tell, that pedestrian was moving pretty slowly and moving at a pretty regular rate. So not zigzagging or moving in some erratic way, but moving pretty consistently. So that means that those sensors on the vehicle should have picked that pedestrian and bicyclist up several seconds earlier.
And that job of taking the LiDAR data, trying to classify that into a pedestrian would have been the responsibility of the Uber software running on the vehicle. It may well be that that particular classification was not successful. So then the question becomes what failed? It could be that the sensors, the radars or LiDARs had a hardware failure. It's possible that the computing hardware that receives the sensor information and does the processing, maybe the computer had failed. So there's clearly a set of technology issues that Uber needs to look into very deeply in excruciating detail.
Are you guys still on the lunchtime? Did you do the induction thing with the I can I do that.
Right.
More effective for you guys here in.
Yeah.
Hey, it's Andy with.
No, I haven't seen it. No.
Some cases probably are more
Stringent, cautious.
Maybe cautious and more worried about that. Doesn't bother me. Up to the age now where one Diana. I give up, right? So what does it do? Come back, give it handy, but you're drinking. I'll back you up and put it.
Do you know is there any way to get laptops like that?
This thing called EduRoam. Wi-Fi connection called EduRoam. See these guys here? That's how I look up, it flashes orange. A good sign. EduRoam is a worldwide educational network called the colleges and universities use, right? And it works anywhere in the world with the university. It's like it's a full email and then the password. If it's not full email, it's just your first part of your email, the user student ID, one or the other, right? Okay. And it works 90% of the time. Sometimes with Max it can be a little bit.
Like everything else is Max.
You know me and Max, don't you? Not take a spam. But what it is another device trying to connect to the network. And the security settings might match up to the security settings the network requires. But the IT guys can come around and put a wee patch on your Mac and make it a new computer. Only way you can look at this is net cable. The network device is talking here, but they haven't the rest of it. What's I'm just not connecting. Yeah, you can use that for it. You can get a Type-C converter. I have a get it on, but I think I have one. So just get a Type-C with an Ethernet at the end of it, right? And then you can plug into one of these leads hanging around your room somewhere. Well, here, try this here. Try Max Power. Are you friendly? So you go to buy a router and decide to buy the biggest, most powerful piece of buy. Right? You can probably pick that up on our lab. What's up with what SSID in there? What's up? Like the Max Power one? Or maybe you could just call it something like Darkness. They got the package on there, I think. Max Power. There you go. There's two. There's Max Power 2 and Max Power 5. Oh, that's because it's got a 3.4 gigahertz and 5 gigahertz. Okay. So your laptop wants to fix up to 5, so use that one faster. 5 gigahertz gives you more bandwidth, but not as big a range. Like I use it in the house. I use those. The password on it. Yeah, I go around and it's something like password 01 or something that you have to follow key. It's not a very complicated one because he doesn't care who uses it. They bypass the whole network.
We're just connecting to James is just connecting to the on-site Wi-Fi here for you guys at home, so he can take you through it when he'll be the expert then when you all come in.
I'll go ahead and get the password before you get to that room. That'll be perfect. That's one. Do you get connected, do you? No. I'll swap that one. Edge room? Edge room. Oh, you put on that game. It's a Connie, so it's a or Max Power. I get the password. So I can use that. I don't go through my own guys, just think I forgot about them.
Right, you guys at home, are we all seeing the PowerPoints again? Yeah? Happy days.
Yep.
Okay, so what did everybody think of that self-driving car? Do you think that if you were driving the car at night, that you would have seen the pedestrian walking across the road with a bike on a fast road? No?
Looking at that video, I don't think I'd have seen them until the last minute.
Agree.
Yeah, and then you have the option then, what should the self-driving car do? I think in this instance it wasn't programmed for jaywalkers, it wasn't programmed to take into account, people walking out in the middle of a highway or whatever, but if it did see them, what should it do? Should it go into the opposite lane? If it was going too fast to stop, what should that car do? So the makers of these, it's all very up for debate. And these self-driving cars are still a fairly new and recent thing. Tesla is kind of at the forefront of it, but I know there is other ones as well. But they're claiming, the manufacturers of these self-driving cars are claiming that they are already much, much safer than a human driving a car. And that's just because of their quick reaction time, because of the technology, it's because of the 360 view and perception of the road and of any obstructions around. So the statistics at the minute show that these self-driving cars are safer. What an interesting one. So AI data exposure. A facial recognition software organization called Clearview, you might have seen this in the press, suffered a data breach. Their databases have over 3 billion photos of people, of individuals, and there was a breach. So them photos got released. Hackers went in and got just those identified their faces of the facial recognition. So there's some links here if you want to read those articles later. Accessibility issues. So there are some accessibility issues still with artificial intelligence. It's trying to cater for more and more people, like we've seen for the sight impaired guy in the video near the start of the class. There is more and more technology coming out to help people with disabilities and accessibility, but there are still limitations. So Alexa, Google Home, systems like that, they're really useful, but for deaf and blind users, there are some limitations. So there's a lot more work needed to put in to make sure that regardless of somebody's ability, that the artificial intelligence, that these products are accessible and that everybody, regardless of their ability, can use these products. So there's a huge focus on accessibility at the minute, making these products available for everybody, regardless of their ability. So trusting complex AI systems. I think somebody mentioned earlier about trust. Do you trust artificial intelligence? What is it? Do you understand it? So AI systems can be very complex and hard for users to understand. Algorithms, sometimes, just imagine it as this black box. There's terminology called black box, whereas you put something in, you get something out, you don't know, maybe you don't care what happens in the meantime, if you don't know what that process is, you're not sure what the algorithm is doing, why the output is as it is, or why certain decisions are made. It's this black box theory that you don't know why it's happening, you just know to trust the output. And that's basically what we'll be doing in this module. We'll be looking inside that black box, understanding why this model is making the decision it is, why the output is as it is, and then going back, refining our models, testing models and evaluating them and making sure that you're making the decisions that we would want them to make. So that testing is really, really important to make sure that the models working properly. So trusting this artificial intelligence. So artificial intelligence is used everywhere across every industry, especially in tech, but not only tech, financial services. So if you ever apply for a loan, apply for any kind of finance, put in your details and then you're given yes or no. You're accepted or your loan is rejected. If you're accepted for a credit card or a loan, you're given a credit limit. All that is based upon an algorithm. So this algorithm will take the information you give it. So it'll take your job title, it'll take what industry you work in, it'll take salary, it'll take your credit score, your credit information. It'll look at, have you had any bankruptcies, have you had any PDAs or any defaults in previous loans? Do you have any other loans out? What's your income versus your outgoing? What's your expenditure like? It'll take all that information in and it'll go through an algorithm. Basically, an algorithm is like a flow chart. Do they earn over X amount? Yes, go to the next thing. What is their job title? It's this, okay, next step. And it'll give you a yes or no answer then. Basically, just think of an algorithm as a flow chart. You put in all your details, the algorithm, the machine will work through the algorithm and then give you an answer. So it'll be yes, they're approved. If they're approved, they'll give you a credit limit. If you're not approved, it could be based on your credit information, it could be based on your income, it could be based on a whole factor of things, but it should never be biased. It should never be because you're a male or a female. It should never be because of your ethnicity or anything like that. So yeah, these AI tools are used And we've seen as well in the legal sector as well. They're used for some very important and significant reasons as well. So many users and industries trust these systems without fully understanding how the system is made or how it works. So if you get rejected for a loan, how likely are you to phone up and say, why was I rejected? What are the reasons for me being rejected? If you do that, then you should be told. It should be transparent. AI should always be transparent, be fair, shouldn't be biased. You should be able to know why the machine, why the computer made the decision. And that's what we'll be doing in this module as well. We're given an output. Why was that output what it was? Why was it not A? Why was it B? And we should be able to discuss that, understand it, and be able to back that up. If we're not able to back it up, but if we make the wrong decision, then there's a point in our model somewhere we need to go back. Testing our model, constantly evaluating and developing our models. So AI is now so complex that even some developers are not 100% sure on what is happening in the system. They just know that they are getting outputs that work. If they're getting the data that they want to get, if they're getting the output that they want to get, then they're not interested in what goes on behind the scenes. Although to be using a model, you should know, it should be transparent, you should know what's going on before you ever use it. You should, if you ever go into a role and you're told, use this model, use this program, use this algorithm, you should be able to go through and understand why it's doing what it's doing, and ask questions, because developers at the end of the day are human. There could have been a human error in there could be mistakes in there. With new observations, models should be changed, models should be refined as we get more and more and more data. Liability for AI decisions. So AI is used for many different decisions and is not shielded from bias, like we talked about earlier, and it's not shielded from mistakes either. So when people are building these models, they might put out a character that they should have, they might put in a typo, they might put in the incorrect variable. So they're not shielded from mistakes because they rely on human input. The problem we must deal with now is who is liable for the mistakes that AI makes. So this is very subjective. Who's liable for a car crash if a self-driving car hits a pedestrian? Who's liable for that? If the person was jaywalking, is it their fault for walking into the road and couldn't? Is it the driver's fault because they own the vehicle and they chose to put it on self-drive mode and trust that mode? Is it the manufacturers because self-drive mode has failed for one reason or another? Whose fault is that? Whose fault is it if there's a storm and the car's blown over and drives into a tree? It's on self-drive mode, but is that anybody's fault? I think a lot of these self-driving cars, I think a lot of it will depend on insurance companies going forward, but like I say, it's all still very new, very subjective, and we're learning as more and more cases arise. Responsible AI. AI should be responsible. AI isn't slowing down, like we've seen in one of the first slides. AI is growing rapidly. The amount of personal assistants like Alexa and Google Home has grown fourfold in the past 5 years. The jobs in AI and tech-related industries are doubling over the next 10 years. So AI is not slowing down. AI systems are becoming more and more part of daily life. Every day, most people will interact with an AI system, whether that's logging onto your computer, talking to a bot, whether that's using an ATM, using a self-service checkout at the shop, whether that's using your Alexa when you go home, or having Google Home turn on your lights or turn down your thermostat. AI is all around us. Typically, the law and regulations move at a slower pace compared to how fast technology develops, and the same with AI. So there's really a full link here, and it discusses the worldwide AI regulations in 2020. And technology companies who produce AI tools have their own principles for responsible AI. We'll use, throughout this course, we'll use Microsoft as our benchmark for the AI principles. And we'll look at some AI principles the next slide. But we'll put on these links as well. So Google have their own AI principles, PwC, so all the big companies who have a tech division or tech department who use AI significantly within their work, they should have their own responsible AI principles. And there's one for Accenture here too. So I'll put the link in the Teams chat for the Microsoft Principles of Responsible AI. Now, these Microsoft docs are really, really useful as guidelines. There's a lot of useful information in there as well with regards to AI and machine learning. So if everybody has a read through those now, a read through the principles, and we'll come back at about 12:10, and we'll have a chat on them in more detail. Does anybody have any questions before that? Can everybody get that link okay?
Yep, all good.
Okay, perfect. I'll be here anyway if you have any questions, but yeah, take some time to read through those principles. They're really important to know, and we'll come back here at 12:10.
Right, folks, did everybody get through that material okay?
Yep.
Yeah.
Yep.
So yeah, it's really important to know how companies like Microsoft are trying to make their models more fair, how they're trying to reduce or eliminate bias, how they're trying to overcome measures like security and safety and things like that. So there's 6 principles of responsible AI that she's went through there. Do you want to shout out to 6 of them?
Fairness, accountability, privacy and security, safety and reliability,
Don't give them all
inclusiveness.
away. Don't give them all away, Matthew.
I'll leave the last one to somebody then.
Yeah, go ahead. So I heard 3 there. So 3 other people shout out. What else? What other principles did we go through?
Inclusiveness.
Inclusiveness. Yeah. So there's inclusiveness, accountability, privacy and security, reliability and safety. Which other 2?
Transparency.
Transparency. Yep. And one more. Come on, guys. Beginning with F. They've spent 20 minutes reading them.
Fairness.
Fairness. Yeah. Fairness. So that's the 6 principles of responsible AI that Microsoft have, and we'll kind of use Microsoft as our foundation. We'll kind of use Microsoft as our they'll be the company that will be our guidance basically for responsible AI. So let me share the screen again, and we have one final video.
Yeah. You're in this afternoon in the class, aren't you?
Yeah.
Over in 13 or something.
Melbourne 1, yeah, 13 like that.
One of them was asking me. Here.
I have the routine set up anyway, but
Just in case, I told them there's just in case remote option, but thanks so just checking. In case I got it wrong. Right. See you later. You stay there and I'll be here. Right.
See you later, Josh.
Christine, sorry, there's no sound coming from the video.
Oh, there's no sound?
Yeah, can't hear anything. It seems to be very hit and miss with the sound.
Blame Jeff.
You hear Jeff?
I will blame Jeff.
Oh, we'll blame Jeff. Right. Give me 1 second. Thanks for letting me know.
You know what? It's 12:15 now, so I'll leave that video. The PowerPoint is on Canvas and it's on Teams, so you can watch it in your own time. But we'll have a review of what we learned today. Move this PowerPoint over. Everybody at home still see the PowerPoint, yeah?
Yep.
Yep.
Okay.
Yep.
Brilliant. So today we covered an introduction to AI, the different AI components, mainly machine learning we looked at, and algorithms, the challenges and risks. So the risks with AI, the self-driving cars and things like that, can we trust the AI? Responsible AI principles, making sure AI is fair, mitigating bias, making sure AI is transparent. When we're building these models, we want to know why they're doing what they're doing. We want to make sure that they're built on the right methodology. We want to make sure that they aren't being biased, they are being fair, that they're not using features that they shouldn't be. They're not using features such as gender, race, features that they shouldn't be. And next week we might look at some labs at going through machine learning practically. So can anybody tell me, or everybody, what have you learned about AI today that you didn't know coming into the session this morning? What have you learned from time?
Bias within AI.
Bias, yeah. So bias is massive, and it's something that you might not normally think of when these machines are doing what they're doing. These models are made and they're built in an automated fashion. You would think to trust them, you would think that there would be no bias. Humans aren't evolved, so there shouldn't be bias, but bias does exist, and that's something that you should really be aware of when building your models, using the right features to build them and not using anything that can be discriminatory. Anything else?
Responsible. Like, I never thought about who would be held responsible if something goes wrong.
Yeah, responsible AI. So those self-driving cars, if a car knocks over a jaywalker, like we've seen in one of the YouTube videos, who's responsible? Jaywalker, the person driving the car, who has autonomy of the vehicle, the software provider that gives the software to the car maker, the insurance company, who should be held responsible, who's liable for that damage of artificial intelligence. What else have we learned? What else did we go through? What else did you not know was maybe a form of AI and now you know it is?
Netflix recommendations. Didn't know that was part of an AI.
Netflix recommendations, yeah, so that's built on a model, a machine learning model, and that's refined. Each time you watch something else on Netflix, your recommendations may change slightly, and that's all involved. That's a machine learning model that does that itself. There's not a person behind that saying, oh, you watched, this person watched this, and this, they might like this. There's not a person doing that. That's all a model that's updated itself, machine learning. Anything else? What about you two guys in the room? Did you learn anything today?
Yeah, I think the distinction between AI and learning, I would have made it down. I didn't really realize AI was as broad as.
Yeah, so AI encompasses so much that you do not otherwise know. Machine learning is just one form of that. And what about algorithms? Did anybody know what an algorithm was before? Are they more clear on that now? The difference between AI algorithms and machine learning maybe? Because you hear this term all the time. You hear the term artificial intelligence, you hear the term algorithm, but you might not always know what they mean. Okay, great. You guys at home, is there anybody who will be coming in next week? Or yet to be considered?
For us at Danske Bank, we're sticking with working from home at the moment.
Oh,
So
your office from home as well still, yeah?
For most days, yeah, we're in one day in the office, but I think that's, well, they want to limit people too, so I think that's why they just says no to coming into Met
Okay, is that until further notice?
until further notice. Yeah.
Yeah, same with me and the HSC. I've been told that I'll not be in the office until next year probably, so I have to remain home working.
That's pretty much the same as Alan and Overy.
Yeah. Okay, well, the campus is James and Josh for today. So the campus is here. If anybody does want to come in for classes, it's always, I feel anyway, a lot better for engagement and interaction and, you know, learning off your peers and having kind of open discussions is easier. It's more fruitful, I think, when you're in person. But yeah, the blended learning option is there. And we'll have this Teams call. This is set up for a recurring weekly basis. So we'll have this set up for anybody who can't make it in for the rest of the semester. So at that stage, does anybody have any questions? Anything on the slides we went through today? Anything?
Not on the slides, but how is this?
It'll be 2 pieces of coursework. So the first piece will be 40% of the module, and the second will be 60%. Yet to be decided. Yet to be decided. Huh?
Will that give us? Will that then change the weighting of the?
No, the assignments will be, the first one will be 40% and the second one will be 50%.
So what will be?
We still have to decide whether it'll be a piece of coursework or whether we'll be doing it as an exam. Just because of the COVID restrictions and everything, not everybody could get in to the exam last year, you know, to make it fair and everything. So we kind of changed the coursework, but there is discussions going on, you know, to make it a multiple choice exam. People could do it with randomized questions and things like that. So we might be able to make it into an exam instead of coursework, but we'll know more about that probably next week. Sure. Yeah. But yeah, there'll be two assignments anyway. 40% for the first one, 60% for the second one. And yeah, I'll let you know next week whether there'll be exams, just whether or not it's feasible. Give an exam not on. Did you do coursework last year, or what was it last year?
That's a mix.
It was a mix. Yeah. So we'll just play it by ear. I think we're trying to get back. Everybody, the campus is reopened, so we're trying to get back to the allow exams. That is just the body. Okay, brilliant. Thank you, everybody. If you have any questions on any of that, just drop me a message. We can talk more about the assessment next week. But yeah, like I say, the slides are all on Canvas and we're on Teams. And get on campus if you can.
Thank you.
Are we back at 1:30?
Thank you very much.
We still have Jeff at 1:30, so he's in at 1:30. He's in the same room. So yeah, he'll be here for 1:30. Have you got a Teams meeting set up?
No.
I'm not sure.
Don't see one anyway.
Don't think
No.
so.
Okay, I'm sure.
Yeah,
Jeff
I think
will-
Jeff usually goes into general or just opens it up in the general chat.
Right.
Yeah.
Okay. Yeah. So you will all be. I'm with Jeff at 1:30. So yeah, take a lunch break now for an hour until 1:30. And you'll see him then in the afternoon or. Cloud development. All right. Thanks, everybody. See you next week.
Thanks for staying. Cheers. Yeah. Thank you. Bye now.
Bye.
Yeah.